Swayam Prabha. Digital India. Educated India.
Welcome back to my course, Industrial Biotechnology. Now, I was discussing, up till now we are discussing upstream processing, and in the upstream processing we covered air sterilization and medium sterilization, and how aseptically we can transfer the seed culture in the inoculum vessel. Now, three lectures will be on the downstream processing, because I told you that that beauty of the biochemical process, that from simple one organic compounds we can produce different products. But when we market the products, the product should be in the purified form. The downstream processing deals with the purification of product. And the question comes, how we purify the products. So this couple of lectures will deal with that. And first, I have chosen that solid liquid separation. This is very important aspects in the downstream processing. Now, solid liquid separation involves the separation of two phases, solid and liquid, from a suspension. So, you know that solid may be of different forms. It may be of chemicals, it may be organics, it may be different forms. So it is used in many processes for the recovery of valuable solid components, liquid being discarded, liquid recovered, solid being discarded. I can give typical examples. Suppose when you carry out any fermentation, I can take the example of this penicillin industry. Suppose we use the Penicillium chrysogenum for the production of penicillin. Now, in the fermentation broth, we get the penicillin in the soluble form, in the aqueous media. So first you have to separate the cell. The cell separation, the liquid cannot be discarded. So here the liquid is to be recovered and solid being discarded. Now, in case of citric acid industry, after citric acid, you get it in the liquid form. You first precipitate it in terms of calcium citrate. Now, when you precipitate it with the help of lime, then what will happen? The citric acid goes in the form of calcium citrate with a solid mass. Then the recovery of valuable solid components and liquid components is to be discarded. So you have two different things, recovery of valuable solids, then liquid is to be discarded, or your liquid has to be recovered and solid being discarded. The recovery of broth, both solid and liquid, some cases is required, or recovery of neither phase, or when a liquid is being cleaned prior to discharge, as in the prevention of water pollution. So this is how it is done. Now, stages of separation process. Any separation system design must consider in all stages. The stages are there. The different stages we can have this separation process. One is called pre-treatment, then solid concentration, then solid separation, then post-treatment. The different stages we have. So pre-treatment, solid concentration, solid separation, and post-treatment. The difference that we shall have to. The pre-treatment, let us talk about little bit on pre-treatment, is used primarily difficult to filter slurry, enable them to filter more easily. It usually involves changing the nature of suspended solid by either chemical or physical means, or by adding the filter aid to the suspension to act as the bulking agent to increase the permeability of the cake forming during the subsequent filtration. Let me tell you this, that chemical and biochemical industry, mostly we use the activated charcoal as a bleaching agent. But that a common problem that we have chemical and biochemical industry, that color that present in the liquid, that if it comes to the product, that is not acceptable. So you have to remove the color, and color removal in the chemical or biochemical industry is mostly done with the help of activated charcoal. Now the efficiency of the activated charcoal again depends on the surface area. More surface area, more it will be bleaching property will be more. So your activated charcoal should be very fine particles. Now activated charcoal, as you know, it is perfectly black in color. Now but since it is very fine particles, when you want to separate through the filtration process, there is every possibility that one or two particles, some particles comes out with the filtrate. So this is undesirable. The question comes that how you can how you can separate these fine particles. So what we do, we add some kind of filter aid. What is filter aid? It is a kind of bigger particle which absorbs the fine particles, and since this particle is very big, we can separate it very easily. So this is how we can do that, by adding the solid or filter aid that we have. I can give the example of Solka flock. This kind of cellulosic material that is used largely for the separation of activated carbons. Now pre-treatment that can be has two types. One is chemical and physical. Chemical, we have flocculation, coagulation and pH adjustment, and physical we have addition of filter aid, freezing or aging. So let me explain that flocculation. Flocculation is the floc formation that we know the activated sludge process, that that how particularly the bacterial culture, the size of bacteria is 0.5 to 2 microns. Since the bacterial size is very small, they are very difficult to separate out during the sedimentation process. So it is desirable that they should form a floc. If the floc formation, then and only then the cluster of cells will form and particle size will be bigger, then it will be easily settled down. So for doing so, there is some bacteria, I can give the example, Jogulia remigera. This is used in the activated sludge process. This bacteria has the characteristics of producing the polysaccharide gel, and since it produces the polysaccharide gel, it has the sticking property, because one cell will stick to the other cell. So when cells they stick to the other cell, then agglomeration of that cells will take place. When the agglomeration of the cells take place, then what will happen? The particle size will be bigger. When bigger particle is there, then it can easily separate. That is called flocculation. Now you have similarly we have coagulation. I can give the example of alum that is largely used in the water purification process for the separation of coagulants. Now pH adjustment, that is another way we can also do the pre-treatment. And physically I already discussed about filter aid, then freezing, that we can freeze that, then aging, that is aging. Through aging you allow the material to settle down, so that fine material will settle down and clear things you can take it out. Now there is solid concentration. In solid concentration, part of the liquid may be removed by gravity or centrifugal thickening or hydrocycloning to reduce the liquid volume throughput load on the filter. The solid concentration, this is we can do by sedimentation and the centrifugal settling. This is the two ways we can do that. Now solid separation involves the filter, in which the solid liquids are classified in many different ways. Techniques is called the filtration. For present purposes, a division into those in which the cakes are formed and those in which the particles are captured in the depth of the media is adequate. The cake filters can further be divided into pressure, vacuum, and centrifugal and gravitational operation. So I that filtration, basically this is the media, and this is the filtration hardwares, and this is the suspended particles. This comes, and then this is the driving force, that the pressure across the membrane, and we get the filtered out. It may be defined as the process of separation of solid from a fluid by passing through the same through a porous media that retain the solid but allows the fluid to pass through. When solid are present is very low concentration, that is not exceeding 1% weight by volume, the process of its separation from the liquid is called clarification. So clarification means also that clarification means the separation of solid from the liquid. Now filtration, you can have that we have slurry, we have filter media, we have the kind of sieving that we have, then we get filtered. So slurry, that is the suspension of the filtered, and then this is the materials we put the slurry, it is combination of solid and liquid. Then filter media, that porous media used to retain the solid, this will retain the solid particles. The filter cake accumulate the solid in the filter, this is cake formation is there, and clear liquid passing through the filter, then it comes out like this. Now process of filtration is this: pore of filter media, pores of filter media are similar, are smaller than size of the particle to be separated. Obviously I told you that if the size of the particle is 1 micron, to be separated the pore size would be little bit lower than that. The filter media or media paper is placed on a support mesh, because this is very much required, because we know that when you use the membrane is a flexible material. So we cannot keep the flexible material as such like this. So it should have a supporting disc, and this supporting disc should be perforated. This will be perforated, and then it is put it in a casing, and then if you pass air like this, and then push in a envelope like this, and then we pass air, media, or liquid or whatever you pass, then your solid will retain there, and it goes like this. So the slurry is placed over the filter media, and then due to pressure difference across the filter, fluid flows through the filter media, and gravity is acting over the liquid media. So solids are trapped on the surface of the filter media. This is the process how the filtration takes place. Now mechanism of filtrations are straining, impingement, and entanglement, and the attractive forces. Now straining, that similar to sieving, or that is the particular large size cannot pass through smaller size. I think in some lecture I try to mention that sieving, like 10 to 10/20 mesh, 20/30 mesh. So we have different pore size. So if we have sieving means kind of perforated the disc that we have. So you pass particles of larger size cannot pass, smaller size can pass. That is your straight. Then impingement is that solids having the momentum move along the path of a streaming flow and strike or impinge the filter media, and thus the solids are retained on the filter media. So this is the entanglement, is the particles become entwined, they are entangled in the mass fiber due to the small size of the particle than the pore size. Thus the solids are retained within the filter media. Attractive force, solids are retained on the filter media as a result of attractive force between the particles and filter media, as in case of electrostatic filtration, because if your particle has the opposite side, then you can easily separate it by that it attract the opposite side, and other things will be filtered out. Now we have a typical filter, that filtration surface skin filter and depth well filter. So here you can see that in the surface the suspended particles they accumulated, and in case of depth filter this is accumulated inside this filter media. This is how it the difference. This is called staining or impingement, and this is called entanglement. Now theory of filtration is that the flow of liquid through the filter follows the basic rules that govern the flow of any liquid through the media offering the resistance. A rate of flow may be expressed as the driving force by resistance. The rate of filtration may be expressed the volume per unit time, that is dV by dt. Driving force is the pressure of upstream minus pressure of downstream. Resistance is not constant. It increases with the increases of deposition of the solid on the filter media. Because let me explain that, because suppose this is the filter media, and if the particles that deposited on the surface, and if they close the pore of the filter, naturally the pressure difference will be more. It increases, the resistance will increases with the deposition of solid on the filter media. Therefore filtration is not a steady state. Now the rate of flow will be the greatest at the beginning of the filtration process, since the resistance is minimum. After forming the filter cake, its surface acts as a filter media, and solid continuously deposited, adding the thickness of the cake. That is the normally that is the resistance of related to the several factors given in figure. This is the different factors that we have it depends on surface area, upstream processing, the upstream pressure, downstream pressure, viscosity, flow, everything it depends on that. Now factor affecting the filtration is the pressure, viscosity, surface area, temperature of the liquid to be filtered, the particle size, pore size of the filter media, thickness of the cake, and nature of the solid media. So different factors that affect the filtration process. The pressure drop across the filter depends on gravity, vacuum, pressure, and centrifugal force. So different factors that affects the pressure drops of this process. I can give the example. The pressure differences could be obtained by maintaining the head of slurry of the filter. Just more head, the pressure drop will be pressure difference will be more, and pressure develop will depend on the density of the slurry. Classification of filtration equipment: we have pressure filter, we have vacuum filter, we have centrifugal filter. Now in the biochemical industries, we are interested for the plate and frame filter phase is largely in practice, and then we also use rotary vacuum filter largely in practice, and centrifuge. So I shall mostly concentrate on these three filtration process, because which are in practice in the biochemical industries. Now as for example, the plate and frame filter press, that mechanical device which is specially used in solid liquid separation using the principle of pressure driven, which is provided by a slurry pump, is called as the plate and frame filter press. Now here I want to point out like this, that what do you mean by the plate and frame filter? Plate and frame. Frame, we understand that the frame we have in our door. In the door we can have the frame like this. So this is the frame that we have. That we can have the frame like this. So we can find out this how frame is looks. This is in the door we have the wooden frame like this. So this is the frame that we have, and so what we do that this frame that we wrap with thick the cotton pad, and then the number of frame we bunch together, because this is usually made of wooden and we can easily make hole here. So if you make it whole, we can, with the help of nut and bolt, we can make it fix all together. So we can have number of such, that frame we can bunch together. So it is the mechanical device. We specially use solid liquid separation using the principle of pressure driven, and it provides the slurry pump in the. So how it is done? Because suppose this is the frame here, and we put the thick cotton pad here, and when you pass, suppose thick cotton pad is here, and if we pass this is the thick cotton pad like this, and we pass the slurry, then what will happen with the pressure? Liquid will comes out like this, and solid material that accumulate inside this the thick cotton pad, and when it is full, then you stop the operation and take this out. So fixed volume and batch operation. This is usually the batch operation, usually made of aluminum alloy. The frame contains an open space inside where the slurry reservoir is maintained for the filtration and inlet to receive the slurry. The plate is studded or grooved surface to support the filter cloth and outlet. So I told you the wooden thing can be made of aluminum also. This is in practice, because then what is the principles? The mechanism is surface filtration, that slurry entered into the frame by pressure and flow through the filter media. The filtrate is collected on the plates and sent to the outlet. The number of frames and plates are used so that the surface area increases, and consequently large volume of slurry can be processed simultaneously with or without washing. This is largely in practice in the baker's industry. Now if you look at here, that plate and frame, that what I was telling, this is your cloth. Am I right? This is your cloth, and here the filter is coming out, and here you do have the feed. When your feed is coming, and this is the filter, cloth filter, and the liquid will comes here, and filter is going out like this. This is the channel through which the filter is going out, and this is how this plate, they are bunched together. And question comes, how one understand that when you find out that this cloth is totally full with the cell, with your cell mass, how you can find out? Because this is usually connected with the manometer with the slurry finder. If the pressure drop is maximum, then that indicates that it is totally filled with the solid particles. Then you have to stop the operation, is open this plate and take out the cell out from the plate and frame filter press. This is largely in practice in the industry. The application of the filter press is use a variety of different application. Food industry, I told you, baker's industry, mining industry, pharmaceutical industry, chemical industry, wastewater treatment process. Then rotary vacuum filter, this is another very important filter that is used for the separation of the cell mass. Particularly, I want to mention that most of the antibiotics is produced with the help of fungi. I can give the example of penicillin industry. Penicillin is produced by Penicillium chrysogenum. Streptomycin is produced by Streptomyces griseus. So they are all fungi, and these fungi are the bigger particles that can be removed with the help of this rotary vacuum filter. Rotary vacuum filter consists of drum rotating in a tub of liquid to be filtered. The technique is well suited to slurry or liquid with a high solid contents, which could clog other form of filters. The drum may be of 3 meter in diameter and 3.5 meter in length, give a surface area of 20 meter square. So this is now a rotary vacuum filter consists of large rotating drum covered by a cloth, and drum is suspended on an axial over trough containing the liquid solid slurry with approximately 50 to 80% of the screen areas immersed in the slurry. As the tram rotates into and out the trough, the slurry is sucked on the surface of the cloth and rotated out of the liquid and solid suspension as a cake. When the cake is rotated out, it is dewatered and in the drying zone. The cake is dry, become vacuum drum and is continuously sucking the cake and taking the water out. At the final step of separation, cake is discharged as solid products and the drum rotate continues to the another separation cycle. Now this is like this is the drum, this is rotating, and this is the muslin cloth that is on the, and inside we have different pipelines. So we applied the vacuum here, and this is immersed in a trough. This is the trough where your fermentation liquid comes, and it is rotating at very low RPM, 1 RPM, 1 revolution per minute. So here we have a fine knife. So when it rotates, since we applying the vacuum, this cell mass will be dried, and then when it touches this blade, this fine muslin cloth here we have wrapped with the fine muslin and liquid comes up like this. And this is actually that is the photographs that we have. This is the trough where this is suspended solid that we have, and here this is the pipeline where we apply the vacuum. We can apply the vacuum here, and when this rotates in this direction, so when it rotates like this, it sucks the liquid on the surface, solid in the surface, and you can wash with the washing water. This is the washing water, and this is the dewatered zone, and this is the fine knife touch the muslin cloth and take the solid out. Rotary drum dryer is separate the solid particles of the fermentation broth, food, pulp and pharmaceuticals, chemicals and application of metallurgical and treatment process. Now let me close here, because the next lecture I shall cover the centrifugal filter and other downstream processing. Thank you.